Imagine standing at the edge of a hole so deep, so wide that you can't see the other side. The air smells like cold clay and diesel, and then you hear it. Not an engine roar, not a mechanical clank, just a low, steady hum, like the earth itself is breathing. And then it comes into view. A machine so large it has its own internal staircase, so tall it stands higher than the Statue of Liberty, so heavy it cannot travel on any road without destroying it, and so productive that in a single day it moves enough material to fill 2,400 train wagons. This is the Bagger 288, and it is, without question, the most extraordinary machine ever built on land. Today, on Iron Chronicles, we're going deep, not just into the specs, though we'll cover every one of them, but into the story behind this machine, why it was built, what it cost, what it means, and what it says about the strange, complicated world we've built to keep our lights on. Let's start at the beginning. To understand why the Bagger 288 exists, you have to understand a country in crisis. After World War II, West Germany was rebuilding from almost nothing. Cities were rubble, infrastructure was gone, and energy, the kind you need to power factories, heat homes, and run a modern economy, was desperately short. Germany had one advantage. Beneath the flat plains of Rhine-Brown Westphalia, one of the most densely populated regions in Europe, sat enormous deposits of lignite, brown coal. It burns inefficiently and releases more CO2 than black coal, but it's there, millions of tons of it just beneath the surface. By the 1960s and 70s, the Rhine-Brown Energy Company, later absorbed into the giant RWE, had built an entire industrial civilization around extracting that coal. Towns were relocated, forests were cleared, entire landscapes were reshaped. And to keep pace with demand, they needed machines of increasing size. The Hambach strip mine in the Rhineland became the largest artificial hole in Europe. It now stretches 85 square kilometers and reaches depths of over 400 meters. To expose the coal seams buried that deep, you first have to remove everything above them: soil, rock, clay, what miners call overburden. That overburden weighs hundreds of millions of tons. Moving it was the problem, and one German engineering firm, Krupp, had an idea for a solution. In 1973, Krupp, the legendary German steel and engineering dynasty, the same company that had been forging steel since the Napoleonic Wars, began designing a machine unlike anything the world had seen. The brief was almost absurd in its ambition: build a machine capable of removing 240,000 cubic meters of earth per day. That's a football field dug 30 meters deep every single day, continuously, without stopping. It took 5 years just to design it, not sketch it, design it. Every gear ratio, every structural load, every material stress calculation had to be worked out from first principles because there was no blueprint for something this size. In 1978, manufacturing began. 5 more years of cutting, welding, and fabricating parts in factories across Germany, and then the machine was shipped, in pieces, to the Hambach mine, where it was assembled on-site over months. The total cost? Roughly $100 million in 1978. Adjusted for inflation, that's well over $400 million today. The machine they built, officially designated the Man-to-Croft RB288, stands 96 meters tall. That's taller than the Statue of Liberty from base to torch. It stretches 220 meters in length, about 2.5 football fields end to end, and it weighs 13,500 metric tons. When it was completed in 1978, it became the heaviest land vehicle ever built, overtaking the previous record holder, a giant American dragline excavator called Big Muskie, which itself weighed 12,700 tons. Only 5 people are needed to operate it. 5. Most people see photos of the Bagger 288 and think it must work like a giant shovel. Scoop, lift, dump. It doesn't. It's far more elegant than that. At the front of the machine sits the bucket wheel. It's 21.6 meters in diameter, about as tall as a 7-story building, and studded with 18 steel buckets arranged around its rim. Each bucket can hold roughly 4.6 cubic meters of material. The wheel rotates continuously, and as it does, each bucket bites into the earth face, fills, lifts up and over the top of the wheel, and then tips its contents onto a conveyor belt running along the machine's boom. That conveyor belt moves material at roughly 18 kilometers per hour, fast enough that individual chunks of rock blur past. The material travels the length of the machine and onto a secondary conveyor system that stretches back across the mine, eventually depositing the overburden in designated dump areas, sometimes several kilometers away. The entire machine moves on 3 rows of 4 crawler track assemblies. Each crawler track is 3.8 meters wide. Together, they spread the machine's 13,500-ton weight across a large enough footprint that the ground pressure, the weight per square meter, is actually comparable to a human foot. That's an extraordinary feat of engineering. A machine weighing 13,500 tons exerts roughly the same pressure on the ground as you standing on your living room floor. The machine is powered entirely by electricity, fed through thick cables from the external grid. It draws 16.56 megawatts of power, enough to supply electricity to a city of roughly 20,000 people. There is no fuel tank, no diesel engine. The Bagger is essentially a plug-in appliance, just one that weighs more than 30 Boeing 747s. And those 5 operators? They sit in a climate-controlled cabin at the top of the machine, monitoring systems on screens and adjusting the direction and bite of the bucket wheel with precision controls. The machine does the brute work. They manage the intelligence. By the year 2000, the Bagger 288 had done its job at the Hambach mine. The coal seam it had been clearing had been fully exposed. Rheinbraun needed the machine at a different mine, the Garzweiler strip mine, located 22 kilometers to the north. Now, 22 kilometers is nothing, a brisk morning's bike ride, but for the Bagger 288, it was a military-scale logistical operation. The machine weighs 13,500 tons. Every road in Germany has a maximum load rating. A single crawler track of the Bagger 288 would exceed that rating on contact. You can't put it on a truck. It is the truck, and the truck is the size of a small town. Disassembly would cost more than just moving it intact. So the decision was made: walk it. In February 2001, a team of 70 workers and engineers began the 3-week trek. The Bagger moved at a maximum speed of 10 meters per minute when traveling, about 0.6 kilometers per hour. The path had to be carefully plotted to avoid steep gradients the machine couldn't safely traverse. The team crossed Autobahn 61, a major German motorway, which required closing the road and laying down heavy steel ground plates to distribute the load. They crossed the river Erft by placing large steel pipes through the riverbed to carry the water, then building a temporary earthen causeway over the top, smooth enough for the crawler tracks. Railroad lines were crossed. Several small roads were flattened and resurfaced after passage. Special grass seed was planted on farmland to restore it as the machine crept across. The total cost of the journey, around 15 million German marks, approximately 10 million US at the time. And here's what makes this remarkable. The entire time, the Bagger 288 remained connected to the electrical grid. It carries a 1-kilometer-long cable reel on board, and engineers connected and reconnected it to different points in the industrial power network as it moved. The machine never went dark. When it reached Garzweiler, it had barely paused. It was back at work within days. In 1995, while the Bagger 288 was still working at Hambach, a new machine arrived. Built by TAKRAF, another German engineering firm working under the broader Krupp umbrella, the Bagger 293 was slightly larger in every dimension that matters. At 225 meters long and 96 meters tall, it matches the Bagger 288 in height, but is just a few meters longer. The critical difference is weight. The Bagger 293 tips the scales at 14,200 metric tons, making it officially the heaviest land vehicle ever built. It operates in the same lignite mining region of Germany, today working at the Hambach mine that the 288 left behind. Its daily excavation capacity matches the 288, 240,000 cubic meters, and it too runs on just 5 operators. Together, these two machines represent the absolute upper boundary of land vehicle engineering. There is nothing on Earth heavier that moves under its own power. Numbers can numb you. 13,500 tons, 220 meters, 240,000 cubic meters. After a while, big numbers all feel the same. So let's make it real. People who've worked at the Hambach and Garzweiler mines describe the Bagger 288 the way you might describe a mountain. It doesn't feel like a machine, it feels like a geographical feature. You don't notice it moving because the motion is too slow for your brain to parse in real time. And then you look away for an hour, look back, and the landscape has changed. The earth face it was cutting is gone. The machine has advanced. The noise is unexpectedly subtle. You'd expect something of this scale to be deafening, but the dominant sound is the hum of the motors and the rhythmic clatter of the conveyor, almost meditative once you get used to it. The bucket wheel itself, at distance, sounds less like excavation and more like a very large clock. The workers who maintain it, the electricians, the mechanics, the conveyor technicians, work inside the machine during operation. There are internal walkways, access hatches, rooms. It has a kitchenette and toilet facilities on board. Working a shift on the Bagger 288 means, in some genuine sense, going to work inside a moving building. Here is where the story gets complicated, and I think it's worth sitting with the complication rather than looking away from it. The Bagger is an extraordinary feat of human engineering. It is also, indirectly, one of the largest contributors to carbon emissions in Europe. The Hambach and Garzweiler mines together produce lignite that feeds power stations responsible for enormous quantities of CO2. The Rhineland lignite mining region has, in some calculations, been identified as the single largest source of carbon dioxide emissions in all of Europe. In 2018, that contradiction exploded into global headlines. Environmental activists had spent years occupying the Hambach forest, an ancient woodland that had been standing since before the Roman Empire, and that RWE was clearing acre by acre to expand the mine. The occupation, tree houses up to 25 meters high, home to dozens of activists for years, ended when police moved in to evict them. The footage circled the world. Tens of thousands of Germans marched, and the German government was forced to act. In 2019, Germany committed to phasing out all coal-fired power by 2038. RWE subsequently committed to ending lignite extraction at Garzweiler by 2030. The Hambach forest at last was officially saved from further clearing. What does that mean for the machines? The Bagger 228 has operated without a single major mechanical failure since 1978. It was built to last. But eventually, perhaps before 2030, it will do its last pass. The bucket wheel will slow, the conveyor will stop, and Germany will have to figure out what to do with a 13,500-ton monument to a way of powering civilization that is coming to an end. There is something genuinely moving about that, even if you believe, as most scientists do, that ending coal is the right thing to do. These machines are not villains. They are tools of their time, extraordinary tools built by brilliant people to power a world that needed powering. I want to leave you with one image. It's 2001, February. The Bagger 288 is in the middle of its 3-week walk from Hambach to Garzweiler. It's early morning. The machine is crossing a stretch of German farmland, flat, frostbitten, ordinary, and 70 workers are gathered around it in hard hats and high-visibility jackets, guiding it meter by meter. From a distance, it must look insane. A machine the size of a small city crawling at barely half a kilometer per hour, surrounded by people who look like ants. But those people know every bolt and wire and motor on that machine. They built their careers around it. Some of them probably grew up in villages that were relocated to make way for the mines it serves. The Bagger 288 is a machine that exists at the intersection of everything that makes human civilization extraordinary and everything that makes it complicated. Precision engineering at a scale that still takes your breath away. Power generation that kept the lights on for millions of people for decades. And an environmental cost that we are only now, finally, beginning to reckon with. That's the thing about truly monumental machines. They're never just machines. They're decisions. Decisions made by engineers, by energy companies, by governments, by all of us, about what kind of world we're building and what price we're willing to pay for it. The Bagger 288 will work until it doesn't, and when it stops, we'll have to look at the hole it leaves, in the landscape and in the question it has always been silently asking, and decide what comes next. Thanks for watching Iron Chronicles. If this kind of deep, honest look at the machines that shape our world is something you want more of, subscribe and hit the bell. We'll see you in the next one.